Dear students, today we are going to start third module, that is Hive. So what do you mean by Hive? We need another data warehouse system because large amount of data is producing every day. Then we last module we studied about Hadoop experiment. We are using Hadoop file system, and it is already it is scalable and it is available, but there are different problems related to Hadoop. One is it is lacked expressiveness, and that we use MapReduce programs, and it is hard to program. So because of the difficulties, the Hive emerged. So what is Hive? It is a system for managing and querying unstructured data as if it were structured. It's a system and it is used for querying unstructured data, and it uses MapReduce for execution, and it uses HDFS for storage. There are different building principles behind this Hive. One is we use SQL, that we already familiar with the data warehousing tool, and another is extensibility. It means that pluggable MapReduce scripts in the language of your choice, rich and user-defined data types, user-defined functions. And another is interoperability. It means it is extensible. It's a framework for support different file and data formats, and the performance is also good. And we will look what are the features of this Hive, and it supports large data sets stored in Hadoop HDFS and compatible file systems such as Amazon S3 file systems. And another feature, the different features is there. One is it provides an important feature is SQL-like language called HiQL, and it is similar with our SQL language with a schema on read, and it converts queries to MapReduce. Then indexing to provide acceleration and index type including compaction and bitmap index is there. Then Hive stores metadata in an embedded Apache Derby database, and other client server databases like MySQL can optionally be used. Then operating on compressed data stored in Hadoop ecosystem is possible, and built-in user-defined functions is there to manipulate dates, strings, and other data mining tools. And Hive supports extending the user-defined functions to handle use cases not supported by built-in functions, and it manages a wide variety of data. And using Hive, the Hive developers can structure and map file data into RDMS concepts. RDMS concepts means tables, columns, rows, and partitions. There is a Hive looks like SQL language, thus it becomes declarative language. You can specify what should be done rather than how should be done. Optimization is difficult in Hive since Hive depends on its own optimizer, and it is very easy to use. Hive is very special since it almost looks like SQL, and developers in Hive commands are excited to use it. And the nature of usage is Hive is mostly in analytics area. While generating reports, people prefer to code in Hive than Pig. If a query is minimum of joins and filters, you can go ahead with Hive. If a query has lot of joins, Hive may degrade the performance. Then Hive handles structured data very efficiently, and Hive represents the data in terms of tables. It is difficult to store the intermediate result in Hive. So we have to create a table and insert the values from another table. Thus, when a complex query comes into picture, Hive code may exceed hundreds of lines. And versatility in case of Hive is user-defined functions in Hive is complex. Maintenance on Hive is very easy. Then for persistence means in Hive the tables will remain with life even you quit the section. This is because the external tables will still point to HDFS files. And considering the development time, as it is a SQLish language, development time is very less. And compatibility means most of the SQL statements that you executed in your RDBMS can already put in Hive. It will work. Then Hive handles big data, and Hive is used by Facebook. These are the features regarding Hive.